Grand Teton National Park, Bridger Teton National Forest.
Parts of Grand Teton National Park in Wyoming are now closed to the public as a dangerous fissure has opened.
A remarkable and deeply unsettling geological event recently captured the attention of scientists and the public alike when a significant fissure opened in the Earth's surface within the Grand Teton National Park. This dramatic rupture was not merely a crack in the ground, it represented a broader and far more dangerous tectonic process at work beneath one of the United States' most iconic and geologically active landscapes. The U.S. Geological Survey USGS responded swiftly to the emergence of this phenomenon, issuing a stark warning that underscored the seriousness of what is unfolding in the region. Before we start, smash the like and subscribe buttons for more updates. Located in northwestern Wyoming, the Grand Teton region has long been recognized for its volatile geologic setting. It sits adjacent to the massive Yellowstone caldera, a supervolcano with a history of cataclysmic eruptions, and lies directly over active fault lines capable of producing large earthquakes. The area's dramatic mountain ranges and deep glacial valleys tell a story of constant transformation, one driven by the relentless pressures of the Earth's crust shifting over time. The sudden opening of a massive fissure, however, signals an acceleration or escalation of these processes that is drawing concern from geologists and emergency planners. The fissure reportedly appeared suddenly, stretching across a significant expanse of the park's rugged terrain. Early field observations indicated that the crack extended for hundreds of feet, cutting through forested areas and rocky slopes with startling abruptness. In some areas, the displacement was so severe that sections of earth on either side of the fissure appeared at different elevations, forming miniature cliffs where there had once been continuous ground. This wasn't a subtle change. It was the kind of rupture that visibly alters a landscape and speaks to immense forces building just beneath the surface. What makes this development particularly troubling is its potential connection to regional tectonic and volcanic systems. The Teton Fault, which runs along the base of the Teton Range, has been the subject of scientific scrutiny for decades. While it is known to produce significant earthquakes, it has been relatively quiet in recent history. The sudden appearance of a large fissure could be a surface expression of deeper movements along this fault line, an indication that stress is accumulating and being released in ways that could precede larger seismic events. Adding another layer of complexity is the proximity of this activity to Yellowstone National Park. The Yellowstone supervolcano, while not directly beneath Grand Teton, lies within the same broad volcanic and tectonic province. The interaction between fault systems, magma movement, and crustal pressures in this region is intricate and not fully understood. Scientists monitor Yellowstone's geothermal features constantly for signs of change. Earthquakes, ground uplift, and gas emissions. The new fissure at Grand Teton has reignited concerns that these seemingly separate geological features could be more interconnected than previously thought. One of the most immediate implications of this event is the potential for increased seismic risk. Fissures of this nature don't appear in isolation. They are typically symptomatic of broader structural shifts in the Earth's crust. If this fissure represents the surface expression of deeper fault movement, then the likelihood of a significant earthquake in the near future may have increased. Grand Teton and the surrounding regions have experienced large quakes in the distant past, and this new development suggests that the cycle of tectonic stress accumulation and release may be approaching another critical juncture. Furthermore, the formation of such a large fissure poses substantial risks to anyone in the area. Hikers, tourists, and park personnel are particularly vulnerable, as the ground can become unstable with little warning. Secondary collapses or the widening of the existing crack could lead to injuries or fatalities if people are too close when the Earth shifts again. Beyond the direct physical hazard, there is also the potential for the rupture to impact infrastructure. Trails, roads, and park facilities that cross or lie near the fissure may become unsafe or unusable. In a region that welcomes millions of visitors each year, ensuring public safety becomes an urgent priority. The ecological consequences of the fissure are another area of growing concern. The Grand Teton ecosystem is a delicate balance of plant and animal life that could be significantly disrupted by the ground movement. Soil displacement and changes in water drainage patterns may affect vegetation, while animals that depend on certain habitat conditions could be forced to migrate or perish. In a worst-case scenario, the rupture could even interfere with underground water tables, leading to drying of streams or alteration of wetland areas that are vital to both wildlife and the overall health of the environment. There is also the specter of volcanic activity to consider, even if it seems remote. Though Grand Teton itself is not volcanic, the proximity to Yellowstone means any significant geological shift must be evaluated for its potential to trigger or be connected to volcanic unrest. A fissure of this size might be caused by fault movement, but it could also be the result of magmatic activity, magma pushing toward the surface, creating fractures as it displaces the rock above. While current data from the USGS has not confirmed such a process is underway, the very possibility demands close and continuous monitoring. Seismic instruments and GPS monitoring stations across the region have been providing data since the moment the fissure was first detected. Early readings suggest subtle changes in ground deformation patterns, movements that, while not immediately alarming, could evolve into more serious anomalies. Ground uplift or lateral shifts in the landscape are often precursors to both earthquakes and volcanic events. The current situation demands that these indicators be watched with utmost vigilance, as the difference between a small event and a major catastrophe can hinge on slight variations in subsurface pressure and stress. The fissure also serves as a reminder of the immense geological dynamism that defines much of the American West. These landscapes, as awe-inspiring as they are, rest upon shifting foundations. Mountains are born, valleys are carved, and Earth itself splits open not in centuries, but sometimes in mere moments. The forces that shaped the Tetons millions of years ago are still at work, and their power is anything but spent. Modern society, with its roads, buildings, and predictable rhythms, often forgets this reality. But nature, through events like this, asserts its presence in stark and often terrifying ways. Public reaction to the fissure's appearance has been a mixture of fascination and fear. While some are drawn to the drama of such a powerful event, others worry about what it might signify for the near future. For local communities, especially those dependent on tourism, the economic implications could be substantial. Park closures, rerouted roads, and reduced visitor numbers would all take a toll. But even more pressing is the need to keep people safe without inducing unnecessary panic. Balancing transparency with caution is the task now facing both scientists and park authorities. The role of the USGS in managing the situation cannot be overstated. Their rapid deployment of monitoring equipment, thorough analysis of data, and clear communication with the public have helped provide a measure of clarity amid uncertainty. The agency's warning is not an alarmist outcry, but a sober assessment based on patterns observed in similar geologic settings. When the ground opens in such a dramatic way, it is never a benign event. It always signals movement, change, and potential hazard. The responsibility now is to interpret those signals correctly and prepare accordingly. This fissure may also prompt renewed investment in geologic research across the region. Satellite imagery, LiDAR mapping, and advanced modeling techniques could help identify other areas of hidden instability. Understanding how faults interrelate, how stress travels through the crust, and how small changes presage larger events is a frontier of science with direct consequences for public safety. The Grand Teton rupture is a real-time case study, an opportunity to learn more about the anatomy of a geological shift before it escalates into disaster. Beyond the scientific and technical, there's a philosophical dimension to this event as well. The sudden appearance of a massive crack in the earth challenges human perceptions of permanence and control. It's a reminder that the surface we walk on, as solid as it seems, floats upon a roiling mass of heat and pressure. That reminder carries with it a certain humility. Despite satellites in the sky and sensors in the ground, some forces remain fundamentally beyond prediction or prevention. Recognizing that vulnerability is a necessary step in coexisting with a dynamic planet. At the same time, it's a call to vigilance and preparedness. History has shown that major geological events often come with precursors. Ignoring those signs or failing to act on them due to complacency or lack of resources has led to preventable tragedies. The Grand Teton fissure should not be dismissed as an isolated or freak occurrence. It is a sign, one that geologists are trained to interpret and one that communities must heed. The landscape will continue to change, as it always has. But with each shift comes an opportunity to understand more, to prepare better, and to respect the power beneath our feet. The Grand Teton Fissure, with its jagged edges and uncertain implications, is not merely a crack in the ground. It is a portal into the processes that shape the very structure of our world. Watching closely, listening to what the Earth tells us, may be the best and only way to avoid being caught unaware when the next movement comes. As the days pass and data accumulates, the picture will become clearer. But one fact remains undeniable even now. The Earth has moved in Grand Teton, and it has done so with a force and clarity that demands attention. Whether this event marks the beginning of a larger sequence or stands alone as a dramatic reminder of tectonic vitality, it is dangerous precisely because it challenges assumptions of stability. The mountains may stand still to the eye, but the ground beneath them does not, and in that movement lies both danger and discovery. The emergence of the fissure in Grand Teton serves not just as a geological spectacle, but as a catalyst for reconsidering the broader vulnerabilities and preparedness of regions situated atop complex tectonic systems. When the Earth splits open, as it has now done in such a stark and visible manner, it lays bare the hidden energy surging beneath the crust. While the visual fracture captures attention, the invisible dynamics that caused it are what truly concern geoscientists. These underground processes are often silent for decades, building stress gradually until that pressure is released in bursts of seismic or tectonic activity, each one potentially more significant than the last. A fissure of this magnitude in an area not historically known for frequent surface ruptures hints at a deeper reorganization of stress fields within the lithosphere. In the larger context of plate tectonics, even minor shifts in one region can redistribute force across an entire system. The western United States is riddled with fault networks, many of them interconnected through subsurface geometry. When stress builds in one fault and is partially released, it can cause adjacent faults to adjust accordingly. This process, called stress transfer, can increase the likelihood of movement across other vulnerable zones. The Grand Teton Fissure could therefore be the first visible symptom of a more extensive chain of crustal responses that may play out over weeks, months, or even years. This phenomenon brings up an important consideration: forecasting. Predicting earthquakes or tectonic disturbances remains an imperfect science. While the presence of fissures, ground deformation, and microseismic swarms provide strong clues, they cannot definitively pinpoint when and where a major event might occur. What the Grand Teton Fissure has provided is a tangible physical marker that warrants closer surveillance, not just locally, but regionally. It compels authorities and research institutions to re-examine their models, update their risk assessments, and consider new zones of potential concern. From a technical standpoint, the challenge now shifts to integrating this unexpected surface rupture into existing tectonic frameworks. Researchers must revise stress maps, incorporate real-time GPS displacement data, and simulate how this new deformation interacts with known fault structures. The possibility that the fissure represents a new or previously unmapped fault line is not to be dismissed. While the Grand Teton Fault has been extensively studied, nature often defies classification. Smaller auxiliary faults can exist in close proximity to major ones and may be the first to rupture under growing tectonic strain. These secondary faults, often referred to as blind faults if they don't reach the surface, can produce significant seismic events on their own. The topography of the Grand Teton region itself also adds complexity. The mountainous terrain imposes unique stress configurations on the Earth's crust, which can amplify or dampen seismic energy depending on the angle and depth of fault movement. Steep inclines, loose talus slopes, and glacial deposits can shift dramatically during ground motion, posing substantial landslide risks. A large rupture beneath or adjacent to an existing slope could trigger cascades of rock and soil that devastate natural habitats and any human infrastructure in the path. Given the ruggedness of Grand Teton National Park, this secondary hazard must be weighed seriously in the wake of any ground-opening events. In a landscape governed by tourism and recreation, the discovery of the fissure injects an element of unpredictability that impacts every facet of visitor engagement. Seasonal visitors, unaware of geological nuances, often engage in hiking, camping, or climbing activities in remote areas where access to emergency services is limited. If the fissure widens or if tremors become more frequent, closures of key trails and high-traffic locations may be necessary, not just to preserve safety, but to avoid mass panic during a potentially volatile event. Managing visitor expectations while conveying the seriousness of the geological situation requires finely calibrated public communication, rooted in transparency but devoid of sensationalism. Geological agencies are likely to respond by deploying temporary monitoring systems in addition to existing instruments. These mobile systems, including portable seismographs and tilt meters, can detect minute shifts in the Earth's orientation or vibrations that signal stress redistribution. A concentrated cluster of such instruments placed around the fissure will allow scientists to triangulate the movement more accurately and build a comprehensive picture of what is unfolding beneath the surface. Furthermore, drones and aerial imaging technologies can offer dynamic views of the rupture's progression over time, identifying any changes in geometry or expansion in real time. Academic institutions may take this opportunity to conduct in-depth field studies. Graduate students and researchers specializing in structural geology, seismology, and geomorphology may converge on the site, eager to collect samples and measurements that could enhance understanding of crustal behavior. Data from these studies will not only illuminate what has happened at Grand Teton, but could provide templates for interpreting similar events elsewhere in the world. The sudden appearance of a fissure offers an unparalleled chance to study an active, developing geological event at close range, something rare and extremely valuable to Earth sciences. The implications extend far beyond academic curiosity. Insurance companies, municipal planners, and emergency management teams rely heavily on geological assessments to shape policies and disaster response strategies. A rupture of this scale introduces new variables that must be accounted for in risk modeling. Property damage, infrastructure degradation, and long-term landscape instability all affect economic resilience in regions susceptible to tectonic upheaval. For nearby towns like Jackson Hole, the fissure could represent a significant shift in geological classification, moving the area from moderate to higher risk zones in the eyes of national agencies. Environmental conservation efforts also stand to be impacted. The Grand Teton region is home to a wide array of flora and fauna that are finely attuned to the terrain's hydrology and stability. A rupture of the ground could interfere with stream paths, water access points, or soil composition. Certain animal species may alter their migratory or nesting behavior in response to perceived danger or habitat disruption. Park ecologists will need to assess these changes closely, as any cascading environmental effects could alter the balance of the ecosystem and threaten conservation progress made over decades. Moreover, cultural and historical dimensions add yet another layer of significance. Indigenous tribes, including the Eastern Shoshone and Northern Arapaho, have deep historical connections to the land encompassing Grand Teton. These communities often hold traditional ecological knowledge that predates modern geological science. Their interpretations of natural events and long-standing oral histories can offer valuable context, especially when sudden natural changes occur. Involving tribal elders and leaders in the interpretation of the fissure's appearance could foster deeper insight while also ensuring that cultural respect is maintained in any analysis or media portrayal. On a more technical level, the interaction between tectonic uplift and glacial retreat could also be at play. As glaciers recede, weight is removed from the Earth's crust, prompting a phenomenon known as isostatic rebound. Essentially, the land springs back upwards. This process can accelerate fault movement or trigger stress releases in crust that has long been compressed by heavy ice. The Grand Teton region, having experienced significant glaciation during past ice ages, is still undergoing slow, cumulative changes resulting from that long-term transition. The fissure may be a byproduct of such a process, adding a climatic dimension to what is primarily seen as a tectonic event. Infrastructurally, questions now arise about how roads, bridges, and utilities that serve the park and surrounding communities can be reinforced or modified to accommodate future movement. If the fissure represents the leading edge of a broader deformation zone, then structures built decades ago under different geological assumptions may no longer be appropriate. Engineers and planners must work in concert with geologists to redesign vulnerable infrastructure to be more adaptable and resilient. This kind of proactive adaptation could mitigate loss during any subsequent seismic or tectonic episodes. Additionally, legal and jurisdictional challenges could emerge. Should the fissure expand or result in significant landscape transformation, disputes over land use, access, and federal versus state oversight may arise. Emergency declarations, land management plans, and jurisdictional boundaries could all come under review. Government agencies like the Department of the Interior, FEMA, and local authorities will need to collaborate closely to navigate the administrative complexities that could be triggered by a large-scale geological incident. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the USGS warning and what you expect will happen? We want to hear from you. Thank you for watching, and see you next time, and see you next time, and see you next time.